Hello students, welcome to your channel Physics Fact. Today we discuss about photoelectric effect.
The phenomena of emission of electron from a metallic surface when light of suitable high frequency and short wavelength falls on it is called as photoelectric effect. That means here we consider the metallic surface. Here this one is the metallic surface and a suitable radiation falls on it. Suitable radiation means that radiation which have high frequency and short wavelength. We know that E equals to h nu. If a radiation or a light having high frequency, it have more energy. High frequency, that means it have more energy. And we know that nu equals to c by lambda. If frequency is more, that means that wavelength must be less. Okay. So here we consider that high frequency and short wavelength of radiation. Short wavelength of radiation. So that radiation, that incident radiation having more energy, more kinetic energy. Okay. When this type of radiation falls on the metallic surface, here emission takes place. The free electron in this metallic surface will acquire energy and able to emit from the metal surface and go towards the anode plate. Here the metallic surface is connected to the negative potential and that another plate is connected to the positive potential. Okay. Here that anode having positive potential and cathode having negative potential. So that free electrons are accelerated or attracted towards the positive plate anode. Okay. The free electrons are attracted or able to accelerated towards the positive potential. And as electrons are flow in a particular direction, so current produced and that current is called as photoelectric current. That current which is produced due to the emission of electron, that current is called as photoelectric current. As photoelectric current is produced inside the evacuated chamber, this photoelectric current is measured by that ammeter and the potential difference is measured by the help of voltmeter. Okay. This is the experimental arrangement of photoelectric effect. To study the experiment of photoelectric effect, the arrangement or the setup which we require is consisting in a evacuated chamber or quartz tube. That means that hole is set up inside a vacuum chamber or evacuated chamber. Now, the two electrode, that is one is cathode, another one is anode, that is connected to the battery. That cathode is connected to the negative potential and anode is connected to the positive potential by means of a potential divider. That means it is connected by means of a rheostat, so that we can able to change the potential between cathode and anode. Now here we know about some basic difference. What is the basic difference? When visible light falls on the alkali metal like sodium, potassium, calcium, electron emission takes place. Okay. In case of alkali metal, when visible light falls on it, emission takes place. But in case of metal like zinc, cadmium, magnesium, if visible light falls on it, then emission does not take place. Here emission takes place only when ultraviolet light falls on it. Clear, student? Now go to some characteristic of photoelectric effect. The first characteristic, effect of intensity of light on photoelectric current. Before go to that characteristic, you first clear that what is photoelectric current. When a suitable high frequency falls on the cathode plate, that cathode plate is the metallic surface. This one is the metal. Okay, when a suitable frequency, high frequency radiation or high frequency light falls on the plate, here free electron acquire energy and able to release from the metal surface. Due to that, electrons are emitted or released from the metal surface and accelerated towards the positive electrode, that is anode. So electric current is set off here. Electric current produced. Now here last point, anode is positive potential with respect to cathode. We allow to set up that anode have high positive potential with respect to cathode, so that free electron get accelerated towards the anode and electric current set up. First point. Then second one, we allow a suitable frequency of incident light. Suitable frequency of incident light. That means suitable frequency means what? That suitable frequency means that frequency must be high and constant. High and constant frequency. That frequency must be high and constant frequency. Here what happens, student? The minimum frequency for which the electron are able to emit from the metal surface, that minimum frequency is known as threshold frequency. That known as threshold frequency. It is the minimum frequency by which an electron able to release from the metal surface. This one is the minimum frequency for this metal surface. For different metal, this threshold frequency value different. So थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा फ्रीक्वेंसी अगर हमारा इंसिडेंट लाइट का रहेगा तो जाके इलेक्ट्रॉन एमिट हो पाएगा. सो दैट फ्रीक्वेंसी वी टेक ए सुइटेबल फ्रीक्वेंसी. दैट सुइटेबल फ्रीक्वेंसी मीन्स frequency is greater than threshold frequency. As we increase the intensity of light, here we see that photoelectric current is also increases. That means if we increase the intensity of light, intensity of incident light, the number of electron emitted from the metal surface or the number of electron ejected from the cathode plate is maximum. As number of electron increase, we know that Q equals to Ne, so that Q is also increase. Also we know that I equals to Q by T. So as the charge is increased, that means that current is also increase. Okay student, you clear it? So as we increase the intensity of incident light, that electric current, that photoelectric current is increases. Then as we take the graph between intensity of light and photoelectric current, we got the graph is a straight line. That means intensity of light is directly proportional to photoelectric current. Now go to the second characteristic. Now go to the second characteristic, that effect of potential of anode A with respect to cathode. That means here also we consider that anode is positive potential with respect to cathode, and here that incident light is a suitable high frequency. That means that incident light frequency is greater than threshold frequency. As we increase the positive potential of anode, the number of free electron get accelerated and attracted towards anode. That means the number of free electron increases so that photoelectric current increases and reach a maximum value. Then what happens? If further we increase the potential, if further we increase potential, then no photoelectric current increases. No photoelectric current increases. Okay, here I'm just give you some example so that you clear about it. So first one, the potential at anode at A, and here the photoelectric current. Okay, so that potential initially 2 volt and that photoelectric current that is 2 ampere. Next, if you increase the potential to 4 volt, that photoelectric current that is 4 ampere. And next you go to increase the potential 6 volt, that photoelectric current 6 ampere. Up to you gradually increase the potential up to 12 volt, that photoelectric current increases and 12 ampere. It becomes 12 ampere and that 12 ampere is the maximum value. Next, if further you increase the potential up to 14 volt, further you increase the potential to 14 volt, then there is no increase in photoelectric current. That current, the maximum current, then further if you increase the potential, then photoelectric current not further increases. That maximum value is called as saturation current. That maximum value of current is called as saturation current. Okay. Now, the next one, if we take the anode plate is negative, here that trick, just a changing moment, that if you take that anode is a negative potential compared to cathode, then what happens? As anode is negative potential with respect to cathode, then what happens? When anode is a positive potential with respect to cathode, electrons are attracted towards anode. Electron attracted towards anode means electrons are attracted towards the positive terminal. But as anode is negative potential with respect to cathode, in that situation, what happens? That electrons are repelled by the negative terminal, or that electron are repelled by the negative electrode. Yes, so that electron, that means photoelectron are repelled by the negative electrode. As it repel all the free electron, then what happens? That photoelectric current decreases. Okay. And further increase the negative potential of anode plate, that photoelectric current gradually decreases and a situation arises that photoelectric current becomes zero. That means no photoelectron reach the plate anode. That means here emission takes place. Electrons are ejected from the cathode plate, but it have no kinetic energy to reach the anode plate, because that anode plate repel all the electron, so it have no energy, no kinetic energy to reach the anode plate. That means that photoelectrons have not able to reach the anode plate. That means that photoelectric current that is zero. Okay. So that potential is known as stopping potential. That potential is known as stopping potential. As we draw the graph on it, you clear about the saturation current and stopping potential. So what do you mean by stopping potential? The minimum potential of anode plate. The minimum potential of anode plate by which the photoelectric current becomes zero. That potential is known as stopping potential and that is denoted by BO. Stopping potential, that is BO. At stopping potential, in case of stopping potential, here what happened? The maximum kinetic energy which electron acquire. Take as this electron acquire maximum kinetic energy. That photoelectron does not reach at anode plate. The maximum kinetic energy of the photoelectron, that means maximum kinetic energy, that means half m v square, that velocity here, that is maximum. The photoelectron which acquire or which contain the maximum kinetic energy, that photoelectron does not or cannot reach the anode plate. Okay, that means this statements represent that kinetic energy maximum, that is equal to EV0. That means here we conclude that kinetic energy equals to half mv square maximum, that is equals to EV0, where V0 is the stopping potential. Okay, this one is the formula, students. You remember it. If we draw the graph between anode potential and photoelectric current, here we observe that as we increase the positive potential on anode plate, here photoelectric current gradually increases. But if we increase the negative potential of anode plate, here this one is the positive potential. Okay, and this one is the negative potential. If we increase the negative potential of anode plate, here photoelectric current gradually decreases. Photoelectric current gradually decreases and reach to zero. That potential, that negative potential, here that potential take as minus 2 volt, that is minus 4 volt, that is minus 6 volt, that is minus 8 volt. That negative potential where the photoelectric current becomes zero, potential is called as stopping potential. And in case of positive potential, if we increase the positive potential of anode plate, here photoelectric current gradually increase up to this much increase, and as further we increase the positive potential of anode plate, that photoelectric current does not increase, it becomes constant. That is the value called as saturation current. If we increase the positive potential of anode plate, that photoelectric current not further increases, it becomes maximum and not further increases. That current is called as saturation current. Here this graph indicates low intensity and this graph indicate high intensity. So low intensity you take as I1 and for the high intensity graph you take as I2. That intensity take as I2. Both having stopping potential same, but that saturation current is different. That low intensity, that means that current is less, but high intensity, that means the saturation current is high. Okay, because we know that intensity is directly proportional to photoelectric current. So low intensity, this one is the saturation current. The value of saturation current is less. For high intensity, the value of saturation current is more. But the stopping potential, that is constant. How? Because the stopping potential EV0 is equals to half mv max square, that is equals to kinetic energy. Yes, that means the stopping potential depend upon kinetic energy of the incident light, not the intensity of the incident light. That means it depends on kinetic energy of incident light means energy of incident light. Or energy of incident light E equals to h nu. That means here the stopping potential is depends on the frequency of incident light but independent upon intensity. Note it student. This one is very important. It comes in your objective type question that the stopping potential depends on energy of the incident light, and energy of incident light we know that E equals to h nu. That means it depends on the frequency of the incident light but independent upon intensity of incident light. Student, you clear on it? Now go to the third characteristic. In the third characteristic, we discuss that the effect of frequency on stopping potential. Okay, that means here we consider, before go to the third characteristic, we just discuss on these two graph, then we go to the third characteristic. So student, here you see that this one is anode potential, this one is the positive potential. We got the saturation current. This one for low intensity light, this one is the saturation current, and for high intensity light, the saturation current that is more. Now, as we increase the negative potential or the retarding potential, as we increase the negative potential of the anode, here photoelectric current that is gradually decreases and reach to zero, and that is the stopping potential. Yes, here we consider the same metal. For same metal, only we consider about two different intensity of light. Now, in this case, we consider about two different frequency. Here, that intensity is different, but frequency remains same. Okay? Intensity differ, frequency remains same. As that intensity differ, the saturation current is differ. Frequency same, stopping potential is same. Stopping potential same means that indicate that the frequency same. Yes student, you clear on it? Now, here we consider two different frequency. That means here we consider two different color of light. Two different frequency, that means two different wavelength of light. Because we know that E equals to HF or that HC by lambda. If frequency different, that means here we consider the incident light, that is two different color of incident light and two different frequency but same intensity. So here what we got? Because of that two incident light have same intensity, so the saturation current for the two incident light is same. Okay, because of the same intensity, the saturation current that is same, because we know that intensity of incident light is directly proportional to photoelectric current. Yes. Now, as that here we consider two different color of incident light, two different frequency of radiation. We take as first frequency that is F1 and another one is F2. Two different frequency of incident radiation. Here we got two different stopping potential. We know that EV0 equals to kinetic energy maximum, and that kinetic energy, that means E equals to HF. So the frequency is different, so that stopping potential is also different. Okay, so the frequency which have low frequency, the stopping potential is also less. That frequency which have high frequency, that stopping potential that is more. Okay student, here you clear that? If we draw the graph between frequency of incident radiation and stopping potential. If we note the reading, that observation indicate that as we increase the frequency of incident radiation, the stopping potential gradually increases. This graph indicates this one. As we increase the frequency F1, F2, F3, F1 is less than F2 is less than F3. Okay, that means F3 is high. As we increase the frequency, the stopping potential that is gradually increases. Okay, so this indicate that here what happens? This one is the photoelectric current and this one is the potential. We just take the reverse form. That means here we take the frequency, this frequency value in along x-axis and the potential along y-axis and see the graph. What happened as we increase the frequency gradually, that stopping potential, that is B0 minus B01 minus B02 minus B03, as we increase the frequency, the stopping potential gradually increases. Here this equation also indicates same, that as we increase the frequency, we know that EV0 equals to kinetic energy. That kinetic energy means the energy of incident radiation, and E equals to HF, frequency of this incident radiation. As we increase the frequency of incident radiation, that the potential, stopping potential, that is also increases. And this formula and this graph both indicate that as we increase the frequency of incident radiation, stopping potential gradually increases. So we got a straight line. Yes. Now, here we got that a very important condition, student. समझो ये बात को. At F0 means at threshold frequency, the stopping potential, that is 0. Okay, this one is the observation, student. What happened? At the threshold frequency, the stopping potential, that is 0. It means at the threshold frequency, no photoelectric current produce. That means photoelectric current, that is 0. Here student, we know that what is threshold frequency. This is the minimum amount of energy by which an electron have the tendency to emit from the surface or emit from the metal. Okay, this one is the threshold frequency. If we do the experiment and we try to eject all the free electron from the metal surface, this one is the condition that frequency of this incident radiation E equals to HF, the frequency of this incident radiation must be greater than threshold frequency. अगर incident रेडिएशन का फ्रीक्वेंसी थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा रहेगा तो जाके फ्री इलेक्ट्रॉन एमिट हो पाएगा और फोटोइलेक्ट्रिक करंट प्रोड्यूस होगा. सो यहाँ पे थ्रेशोल्ड फ्रीक्वेंसी पे कोई भी इलेक्ट्रॉन एमिट नहीं हो रहा है, फोटोइलेक्ट्रिक करंट प्रोड्यूस नहीं हो पा रहा है. सो that indicate the stopping potential, that is 0. Okay, what do you mean by stopping potential? The stopping potential indicate that as we increase the negative potential of anode, that photoelectric current becomes 0. As we take the frequency along x-axis and stopping potential along y-axis, at the threshold frequency, the stopping potential, that is 0. And below the threshold frequency, if we take a incident radiation and that frequency of that incident radiation is less than threshold frequency, that means In this region, no photoelectric emission takes place. And here the negative potential, that is minus V0, here we got the value, this one, minus V0. Okay, stopping potential is lie here. Okay, but at threshold frequency, the stopping potential, that is 0. If we do the experiment successfully, that frequency of incident radiation must be greater than threshold frequency. And if the frequency is less than threshold frequency, no emission takes place. Clear, student? And here some important phenomena, that for different metal, the threshold frequency also different. Here F0 and here that is F01. The threshold frequency, that is different. Okay, student? This one is the condition. Okay, here on it, student. In the next video, we discuss about Einstein photoelectric explanation.